Execute.
SpaceX's Starship is without a doubt the biggest, the most powerful spaceship ever created. Hence, it's the people's favorite, and a lot of us have seen or heard at least of how Starship exploded at its initial test launch and set its course to an imminent obliteration. It all seems very strange how it could blow up when NASA's Space Launch System delivered the Orion spacecraft all the way to the moon at its first attempt. In this episode, I want to dive straight into the full overview and analysis of how SpaceX will forge a path to future success with Starship, regardless of the explosive finale on April 20th. Since it's been more than a month of the aftermath discussions and analysis of the precious data, a comprehensive breakdown of all that has happened led us to clear understanding of what's going to happen next. Here's everything you need to know about the flight of the most powerful rocket ever created. This is Adventures in Space. At 9:33 a.m. Eastern Time on April 20th, the long-awaited moment finally arrived. A fully fueled Starship, accompanied by its super heavy booster, took flight from Boca Chica, Texas. It soared for 4 minutes, reaching an altitude of around 39 kilometers and a maximum speed of 2,150 kilometers per hour. However, at the 4-minute mark, the loss of vector control caused unexpected maneuvers, triggering the flight termination system and resulting in the complete destruction of Starship over the Gulf of Mexico. Typically, a successful first test flight is defined as a successful liftoff from the launch pad, according to rocketry enthusiasts and industry experts. Therefore, despite a few exceptions like the SLS, which successfully reached the moon on its maiden voyage, Starship's initial launch can be considered relatively normal. Nevertheless, right from ignition, significant problems plagued Starship. The immensely powerful Raptor V2 engine array inflicted severe damage on the launch pad, as indicated by the expulsion of a substantial cloud of dust, smoke, and chunks of concrete debris during throttle up on the orbital launch mount. Following the release of the clamps, Starship subtly tilted and moved sideways, likely employing a launchpad avoidance technique to minimize thrust-related damage. However, as the booster cleared the Mechazilla tower, it became apparent that 3 engines did not ignite. From SpaceX's camera angle, the rocket's angle liftoff path and the debris falling into the ocean were visible. Despite the engine failures, Starship remained airborne, as it doesn't require all 33 engines for flight, especially without a payload. As the flight progressed, additional engines started to malfunction, leading to explosions near the engine housing at approximately 30 seconds into the flight. Observers speculate that these explosions resulted from the destruction of hydraulic power units responsible for controlling engine movements and second-stage detachment. Each engine loss constitutes approximately 9% of total thrust, contributing to both the rocket's loss of control and its delayed arrival at max Q, the point of the vehicle's maximum mechanical stress caused by its speed and environmental resistance. At this point, the vehicle struggles to maintain its nose up, facing extreme aerodynamic stress. Up to 8 Raptor engines are lost, accompanied by visible sputtering and flaring from the super heavy thrust section. Unexpectedly, Starship goes through multiple loops while attempting to stabilize, demonstrating impressive structural integrity. It completes nearly 4 full rotations during its descent, even encountering a second max Q event before exploding. The fuselage's durability during this critical moment is remarkable, considering most rockets break apart even with slight misalignment due to their massive size and supersonic speeds. As the first stage booster runs low on fuel and the second stage becomes heavier, aerodynamics, gravity, and inertia exert conflicting forces. The exact moment of Starship's defeat is captured in an image showing the severe bending of the booster, likely caused by missing heat shield tiles. While Starship proves its resilience and capability for orbital entry, the significant damage caused by the Raptor V2 engines remains a substantial concern. 2 days later, images from What About It channel on YouTube reveal widespread debris of reinforced concrete around the Mechazilla tower and damaged fuel tanks, surpassing the protective berm's height. The Mechazilla tower itself appears to have endured the launch relatively well, but surrounding structures, like the drawworks building housing the tower's sensitive lift mechanisms, resemble remnants of a World War II bunker. The damage to the building's door signifies the need for repairs to the lift equipment. Moving closer to the blast site, the orbital launch mount shows significant damage, resembling the harm inflicted by the SLS on the mobile launch platform in November of 2022. Most of the plumbing and shielding appear rough but repairable, unless SpaceX is compelled to dismantle it entirely. However, the concrete pad, or what remains of it, sustained the worst damage, as the new heat-resistant FONDEC proved ineffective, evident in the visible hole. From the evidence, it appears that engine's flames burn through the concrete pad, allowing hot gas to accumulate underground and eventually explode, causing substantial damage to half of the launch mount's foundation. The primary issue with the Starship launch lies in losing the launch architecture due to miscalculated factors. Elon Musk mentioned that SpaceX engineers were developing a better pad option, but it wasn't ready for the first test flight. Debates will likely arise regarding whether waiting would have resulted in a more successful flight with less infrastructure damage. A high-strength and heat-resistant FONDEC concrete installed under the launch mount had performed well during the static fire test on February 9th, but that was with engines at lower thrust. Unfortunately, the Boca Chica pad lacked flame diverters or a comprehensive water deluge system, leaving no outlet for the energy generated, causing it to impact the pad. Recovering from this setback poses a challenge for SpaceX. Elon Musk's claim of being able to launch again in 1 or 2 months seems unlikely. Simply filling the crater, replacing tank farm equipment, and repairing the launch apparatus could be completed with that timeframe, but the issue lies with the strained FONDEC concrete. The ignition debris possibly caused the failure of the initial engines and damage to the hydraulic power units, leading to subsequent engine failures. The amount of damage visible on the drawworks cover suggests the thrust section of the booster could have suffered severe damage, potentially affecting engine functionality. To ensure a successful test, SpaceX needs to finalize their alternative launchpad solution, which involves a water-cooled steel plate. Dr. Phil Metzger, co-founder of NASA KSC SwampWorks, supports this idea, stating that a water-cooled steel plate combined with a water deluge system can handle that heat, force, and noise generated by Starship. By incorporating a constant flow of water, the plate wouldn't need to be excessively large or thick. Once the launchpad issue is resolved, addressing the remaining physical problems becomes more feasible. The explosion of the hydraulic power unit won't be a concern in future rocket versions, as SpaceX has switched to electric thrust vectoring. However, the FAA presents potential challenges as reports of broken windows and particulate fallout from the launch raise safety concerns. The FAA will require safety changes before allowing Starship to fly again, but as of May 15th, SpaceX's requested window for a second Starship test launch between June 15th and December 15th was approved. SpaceX's valuable flight data has been already analyzed and shared with the design team. We may potentially see some rocket redesigns, but so far the Ship 25 iteration of Starship preparing to take some payload on board for the next test. Repairing the damage and upgrading the launch area will also take time. Realistically, this work could extend for several months or even a year, but it is necessary to meet FAA and NASA requirements. If Starship aims to reach the moon, prompt improvements are essential. As for my personal opinion, we will see next Starship launch no later than August of 2023. I hope you enjoyed watching this video, and if you liked it, please consider subscribing to the channel to never miss an update on everything space industry related. We do 4 essays every week, and you have 2 more of them in front of you right now. This was Georgie with Adventures in Space, and I will see you at the next one.